This question reads, what is the state of shear strain gamma x prime y prime for an element rotated 45 degrees from a condition of epsilon x equals epsilon and epsilon y equals minus epsilon? Was the original state a state of principal strain? Is the new rotated state one of max in-plane shear strain? Well, let's go ahead and answer the second question here. So we have that was the original state a state of principal strain? Well, what does this mean? The original state being a state of principal strain, or what is a state of principal strain? Well, a state of principal strain is when the shear strain is zero. Okay, so happens when shear strain is zero, which is analogous to a state of principal stresses, where you have the shear stresses being equal to zero. So in this particular case, it may not be super clear, but the state of stress is epsilon x equals epsilon y equals minus epsilon, and gamma xy is equal to zero. So there's no shear strain, which means that we're going to say that yes, this happens to be a state of principal strain. So this is a state of principal strain, so yes. Or we might say state of principal strains. Yes, it is. Okay. Now let's go ahead and let's take a look at the first question. The first question here is, what is the state of strain for an element rotated 45 degrees from the original state that was given? And so for that, let's go ahead and write out the strain, I almost said stress, but the strain transformation equations. So the strain transformation equations, and we'll get to Moore's circle for strains in a little bit, but the strain um, transformation equations look very similar to the ones that we use for stress. And so I'll try to write them out kind of quickly here. But we have the average of the normal strains plus the difference in the normal strains divided by 2 times the cosine of 2 times the angle of rotation. So in this case, we're going to say that the angle of rotation is going to be theta, and that's going to be equal to 45 degrees. We have plus the gamma xy over 2 times the sine of 2 theta. Epsilon y prime is very similar, and it's the average of the normal strains plus the difference of the normal strains divided by 2 times the cosine of 2 theta again, but minus gamma xy times sine of 2 theta. And gamma x prime y prime over 2 is going to be, this is a little bit tricky. There's a minus sign and then an epsilon x minus epsilon y, all in parentheses, over 2 times sine of 2 theta plus gamma x y over 2 times cosine of 2 theta. And no, these are not equations that I remember in my sleep. These are equations that I would look at and use if for some reason it did not make sense for me to use Moore's circle, which we'll talk about again, but in this context for strain instead of stress. Well, let's take a look at what happens here. Epsilon x prime. So for epsilon x prime, we're going to have the average of the normal strains. Well, we have epsilon plus minus epsilon. Well, that's going to be 0 then. This component right here, sorry, I've lost my mouse. This component right here is the difference, so that would be epsilon minus negative epsilon. So that's going to be 2 epsilon over 2, but cosine of 2 theta, where you have 45 degrees for theta, that's going to be 90. So we would have something like 2 epsilon over 2 times cosine of 90 degrees. And then this last contributor is going to be with the, I'm losing my mouse. Where did the mouse go? Okay, the mouse is gone. It's just going to be plus 0 because there's 0 shear strain initially. Okay, and now epsilon y prime is very similar. This component is the same. This component is the same, and it's minus 0. So epsilon y prime is also going to be equal to 0. And when we come down to the epsilon or the gamma xy, x prime, y prime over 2, okay, we can also see that this component will be equal to 0, but this component, now sine of 2 theta, that's going to be sine of 90, that's 1, and we have epsilon minus negative epsilon, so that would be 2 epsilon up here, and then minus that, so that'd be minus 2 epsilon over 2, so minus 2 epsilon over 2 plus 0, I guess I can say plus 0, that's going to give us a minus epsilon. What does this, what does this state of strain really look like on an element? Well, initially, all right, what we had was something where we had, let's say this is the x direction, and this is the y direction. So you had an element that essentially was getting elongated in the x and compressed in the y direction because it's negative here. Okay, so that's kind of a rough outline of what the straight state of stress look like. For the rotated state of stress, okay, so now if we take a look at what has happened to our element if it's rotated 45 degrees, we can see I've attempted to make it slightly so that this angle down here is larger than 90 degrees and this angle right here is less than 90 degrees. Well, I think about what's happening. You could have a material being stretched in this direction. When it's stressed, the Poisson ratio causes, or the Poisson's effect, it causes it to shrink in that direction. And so an element that was initially very 90, 90, 90 for its square. That's not very good, but you get the idea, right? It's going to get elongated like this. So if we were to draw, now let's look at, okay, something like this. And we can draw the original element inside, okay, something a little bit more squarish. Ooh, that's maybe too exaggerated. Okay, too much. Okay. This is hard for me to do well. Many things are hard for me to do well. Yeah, but let's just say, okay, this is going to be the original element. So maybe it's a little weird to draw the original element in dashed and the new element in solid. Okay, but that's more of a square. And this one has been expanded out like this. So this angle in here, that angle, that's the gamma x prime y prime over 2. And that's the gamma x prime y prime over 2 on this side. Okay, so that is what we're saying is equal to minus epsilon. And if it were positive, if this were a positive quantity, then we would say that the resulting state of stress or state of strain, sorry, would be having a diamond that is going the other direction. So we'd have less than 90 degrees in that x in that bottom corner, right? So we're talking about this being the x prime direction and this being the y prime direction, like that. Okay, and so here that's the same thing. This is the x prime direction, and that's the y prime direction. Anyway, that might have been more information than we wanted here, but we can see that that is how this state of stress will look when we've rotated 45 degrees, assuming epsilon is a positive number itself. So the final question is the new rotated state of stress, just maybe I'll do this, okay, is this new rotated state a state, and I said stress, rotated state of strain, a state of max in-plane shear strain? Well, what is the definition for state of max in-plane shear? Well, it means we typically have, maximum shear stress or shear strain. Okay, and that happens at 45 degrees. At theta, kind of plus or minus 45 degrees, or you could say, something like even plus or minus 135 degrees as well. Okay, or you could keep going around in circles if you wanted, but that's when you're going to happen at plus that 45 degrees to the orientation that has the principal stresses. And so that's exactly what we see here. There were principal stresses, principal strains, sorry, before. I keep doing that because we've talked about stress for so long. And the other thing that we can see is that these epsilon x prime and epsilon y prime are actually equal to 0. So that's another kind of indicator that we're going to be maximizing our our maximum in-plane shear strain. Okay, so maybe I should have been a little more careful earlier, but what is the maximum in-plane shear strain? Well, the maximum in-plane shear strain, or what is the shear strain? The shear strain really is going to be minus 2 epsilon. So I better be careful. Right. Well, I have that right actually. This is correct. That is still minus epsilon, right? But the gamma x prime y prime is going to be minus 2 epsilon. Okay. So yes, the rotated state of shear strain is going to be a state of maximum max in plane shear. Okay, great. Well, I hope this information is useful. Thank you.